we think about medical advancements, we often picture new drugs, better surgical techniques, or cutting-edge imaging technology. But what if the biggest revolution in medicine is happening at a scale we can't even see? In fact, it is so small that it works on a nanometer scale, making it smaller than a single cell in your body. What is it? It's nanotechnology. So, what is nanotechnology? Nanotechnology is the science working with materials at the atomic or molecular level. Imagine tiny particles engineered to deliver chemotherapy only to cancer cells, reducing toxic side effects. There's unlimited amount of potential for what it can do in medicine when we have a vehicle like nanotechnology that is 10 times smaller than bacteria, making treatments more precise, effective, and even less invasive. Nanotechnology is revolutionizing cancer treatments by introducing innovative approaches that enhance the precision and efficacy of therapies. One notable advancement is the use of gold nanoparticles in photothermal therapy. Cancer remains one of the most challenging diseases in medicine. As of 2022, cancer remains a leading cause of mortality worldwide. The International Agency for Research on Cancer, IARC, reported approximately 9.7 million cancer-related deaths globally. Traditional treatments like chemotherapy, radiation, and surgery have saved countless lives, but they often come with side effects, damaging healthy cells and weakening the immune system. Scientists have been searching for better ways to fight cancer, methods that are more precise, less harmful, and more effective. And one of the unexpected but powerful allies in this fight is gold. Gold isn't just for jewelry. It has been used in medicine because it doesn't rust, fights bacteria, and can even reduce inflammation. But something amazing happens when gold is shrunk thousands of times smaller than a human hair. At this scale, gold nanoparticles interact with light in a special way, a phenomenon called localized surface plasmon resonance. Imagine shining a flashlight on a tiny metal object. Instead of just reflecting the light, the electrons on the surface start to vibrate in response. Gold nanoparticles do something similar, but on a much smaller and more intense scale, vibrating to absorb and convert light into heat very efficiently. Scientists use gold nanoparticles in a treatment called photothermal therapy. Here's how it works. First, we start by getting to the tumor. Gold nanoparticles are injected into the bloodstream, where they're naturally gathered in tumor tissues. This happens because tumors have leaky blood vessels, making it easier for nanoparticles to slip in and stay there. Next, doctors activate the gold by shining a safe infrared light onto the tumor. This light passes through the body without causing any harm. Lastly, we heat up the cancer cells. The gold nanoparticles absorb the light and convert it into heat, raising the temperature of the tumor cells and destroying them without damaging nearby healthy cells. Gold nanoparticles come in different shapes, each with its own special properties. Some, like gold nanorods, are great at absorbing near-infrared light, making them perfect for treating deeper tumors. Others, like gold nanostars, have spiky edges that boost their absorption, making them even more effective at treating cancer cells. They can also be functionalized to improve their specificity to cancer cells. By attaching target ligands, such as antibodies or peptides, to their surfaces, these nanoparticles can recognize and bind to tumor-specific markers, ensuring they accumulate precisely. One of the key advantages of gold nanoparticles is their safety. When designed correctly, typically at sizes below 8 nanometers, they can be filtered out of the body by the kidneys, minimizing long-term risks. Scientists can carefully control the size and composition of gold nanoparticles to ensure safe excretion, preventing accumulation in organs like the liver or the spleen. When new technology is developed, there are always challenges. Gold nanoparticles are usually safe for the body, but their potential toxicity depends on their size, shapes, surface properties, and coating materials. Some coatings or leftover chemicals from the manufacturing process can be harmful to healthy cells. Another challenge is the environmental impact. If nanoparticles are not carefully disposed of, they could end up in the environment, especially in medical waste. Once released, they could accumulate in soil and water, where they might harm wildlife and affect natural processes. Nanotechnology in medicine also comes with a very high cost. Developing and producing these treatments require advanced research, expensive equipment, and strict approval processes, all of which drives up the price. This creates a big gap in access between wealthy and low-income countries. Research shows that countries with higher incomes buy more nano-based treatments, while poorer countries often don't have access at all. This creates an unfair situation where people in wealthier countries can benefit from life-saving treatments, but many others can't afford them. Overall, gold nanoparticles are revolutionizing cancer treatments by enhancing radiation and heat-based therapies while sparing healthy tissue. These nanoparticles heat up under light to destroy cancer cells more effectively. Beyond cancer, nanotechnology is paving the way for advanced drug delivery, medical imaging, and even applications in cosmetics or renewable energy. As we continue to explore the nanoscale frontier, the transformative potential of gold nanoparticles and nanotechnology in medicine is infinite. Before we wrap up, let's see how much you've absorbed. Ready for a quick quiz? Let's go! Drop your answers in the comments below. Rewatch the video if you need a hint. First question. Nanotechnology works at a scale smaller than which of the following? A human hair, a red blood cell, a bacterium, or all of the above? What do you think? Let us know in the comments below. On to the next question. Which of these is a key medical use of gold nanoparticles? Building stronger bones, photothermal therapy to destroy cancer cells, enhancing vision, or speeding up metabolism? Did you guess it? Let us know in the comments what you think. Thanks for watching. Hopefully you learned a bit about nanotechnology. And here's a fun fact to leave you thinking. Did you know that a strand of human DNA is about 2.5 nanometers wide? That means the very blueprint of life operates at the nanoscale. No wonder nanotechnology is so powerful in medicine.